and excited to dig into this topic. This is something that we've, of course, talked about a lot since the very start of CoLab. But I think this presentation we're going to give today is the culmination of a lot of research, a lot of conversations with manufacturing companies, some of the folks on this call. And I think this is really going to be clarifying, but also hopefully educational. So I'm excited to get into it. So as Mary alluded to, a couple key topics we're going to cover today. The first thing is, what does the status quo look like? So what tools do companies use during product development today? We're going to talk a lot about MPD, but a lot of this is also relevant in sustaining engineering. We're going to talk about the risks in how companies are collaborating. So you've probably heard us talk about this before. One of the core kind of places where collaboration happens in manufacturing, particularly in engineering, is during design review. So we're going to talk about what the risks are and how most companies are doing design review today. We're going to talk about what engineering teams need for better design review. To some, better might mean more, it might mean higher quality, it might mean faster. We're going to get into that. And then finally, we're going to talk about what exactly is a DES, a design engagement system, and perhaps more importantly, what is it not? And then we're going to talk about when a DES is most impactful. So that's really a sort of use case lens on a design engagement system. And then we'll show some case studies. So we're going to talk about case studies from companies that have strong PLM deployments, have great sort of systems of record, and how they use DES as a real like force multiplier on top of that PLM. So a study was done by McKinsey about this time last year, asking the question, what separates the best manufacturing companies from everybody else? Best defined as most productive in this case. So they're looking at manufacturing productivity and trying to understand across a whole number of sectors what separates the best from everybody else. Interestingly, they found the gap across every sector was the widest in manufacturing. So the gap across the high performers and the laggers, widest in manufacturing, where the high performers were more than 5.5 times more productive than everybody else. It's a big gap. They also found that the gap is widening. So if they looked at that difference in productivity in like the late 80s compared to, say, 2019, that gap was getting 25% bigger. What they found was that gap was increasing in productivity, not because the laggards were getting worse, but because the compounding effect on the high performers meant they were sort of just flying away while the rest were really stagnating. So that's obviously some interesting information, particularly given manufacturing had that widest gap by quite a bit. So then they asked the question, like what are the things that these highly productive companies are doing that's helping them kind of fly away from the pack while the other group stagnates? And they found 4 key patterns, 4 key things. So the first thing, the high performers capture value from digitization. Particularly, they use digitization as a means of strategic differentiation and unlocking innovation, not just cost efficiency. So they're not using digitization to augment what they're already doing and squeeze like 5 or 10% more efficiency out of it. They're using digitization for strategic differentiation, to tap into new customers, new markets, R&D, talent, that sort of thing. Similarly, they invest in intangibles. So these high performers invest like 2.6 or 2.5 times more in the intangibles as everybody else. And how they define intangibles here are things where you can't clearly calculate an ROI right away. So this might be in people, in learning, in R&D. And what they saw is that this really takes a sort of like J curve. So that investment is small, and then they just see it kind of run away very quickly. The third thing, they build a future-ready workforce. Really kind of what the attention was on here in this report and in this study was that they're working really hard to attract top talent, and they're recognizing that employee experience is paramount in doing that. So they're not just competing with pay and that sort of thing. Obviously, that's a critical factor, but they're also recognizing that people need to enjoy the work they're doing every day, or they will go somewhere else. And that top talent is really critical. So that's both at the front lines and also particularly in technically savvy execs was kind of some key points there. And then the last one is that they adopt a systems approach. So they're systems thinkers. They think about how they can leverage the ecosystem they exist in to do better. So one of the critical points here, for example, is that they call on suppliers and customers for innovation. So that might be to access new markets, to access new R&D capacity, to access ideas, talent. They're collaborating more effectively with their stakeholders. So the highest performers are more tapped into that global value chain than everybody else. So, it begs the question, why does this manufacturing productivity gap keep getting bigger? Why do some companies struggle to use digitization as a lever for innovation, not just like a 5% efficiency gain? Why do they find it challenging to attract top talent? Why do they struggle to leverage suppliers and customers? We think a lot of these things are interrelated. And we think that in a lot of ways, this gap is widening because, yes, the compounding effects of implementing these things, but also we think the manufacturing landscape is changing, and it is, in fact, getting harder. So people are falling behind because it's harder to correct these things now than it was, say, 20 years ago. The ones who are set up well are getting this compounding effectiveness gain, and everyone else then is sort of stagnating. So what's changing in manufacturing that's making this more difficult? Well, we think that if we look at R&D, if we look at engineering and manufacturing, it's gotten harder. More folks are involved in a given decision than ever used to be, right? So if we think about 20 years ago, most likely, 2 or 3 people could make almost all of your design decisions. You've got experts in mechanical, electrical, and production, and as long as you can get those people on the same page, you can launch a successful product on time. Today, it just doesn't look like that, right? We've got mechatronics, software, quality, supply chain, all on top of that existing complexity. But folks are really pushing all of that additional complexity through the same process, the same tools. And what we're seeing is that that's then resulting in mistakes, delays, all of these sorts of things as a result of that increasing complexity. So the folks that have figured this out and are able to deal with this complexity and still move really, really effectively, so not just faster, not just efficiently, but they're able to tap into those suppliers to solve something earlier. They're just becoming significantly more productive than everybody else. And we can see this, right? Like we talk about the compounding effect. Over time, we see the difference in a company who invests in how they work together, invests in how they make design decisions, and the ones who really accept the status quo, we see over time that decline. Right. So that's not just about getting products out. That's about attracting talent that are going to figure out what the right product should be. Right. So, I think we can't understate how important this is as it relates to effectiveness, not just efficiency. So doing the right things, not just doing the same things faster. So this is what this kind of decision-making process looks like for a lot of companies. So you've got, some kind of stage gate approach and a series of reviews that happen chronologically or in this waterfall kind of approach. So you have your, engineering review, maybe you engage a cross-functional audience somewhere after, maybe at the end of detailed design. Then maybe right before production validation, we're bringing in suppliers, we're bringing in customers, depending on the industry. We have some amount of rework cycle, and then we introduce a new product. What this means is that you're pulling out all those issues, you can see in the bottom here, somewhere towards like the middle to late part of this process. That's when all those things are getting brought up and then corrected. As we all know, the later you find an issue, the more expensive it is to change, the more difficult it is to change. But if we think about if we could give people a better way to pull that risk forward, well, now we can do some things in parallel. So we can engage engineering, cross-functional folks, suppliers, and customers earlier. And by engaging them earlier and in a more meaningful way, in a more engaging way, well, now we can pull all that risk forward. Sounds simple, but really one thing that we've uncovered here and one thing we spend a lot of time on is that, Engineering teams are not doing the red instead of the blue because they don't believe this or because they don't want to. But it's just really challenging right now with the given tools that they have. So this is often what that landscape looks like. So we've got CAD on one side, right? So the creation tools for design. We've got PLM, like an excellent system of record on the other side. But the process for the decision making to go from something is in detailed design to it's released in PLM and it's good to go, a lot of that today is still governed by emails, PowerPoint decks, spreadsheets, meetings. So it's not that they don't buy into, yes, the blue is better than the red, but the tools for actually enabling that are just very, very challenging. And what we've found is that there is no purpose-built solution to handle what we call the messy middle. So the messy middle being this kind of tangled web here in the center. So what do teams use instead? Well, in the survey Mary alluded to, so we surveyed 250 engineering leaders in the manufacturing space across a bunch of different industries. So automotive, industrial equipment, heavy machinery, consumer hardware. And we asked, what are you using to document design feedback? Number one, by quite a bit, spreadsheets. Everybody, for the most part, is using spreadsheets to document design feedback. Then we see email, and then a couple other things. And we've seen this in the wild, right? Like we've seen folks, with very sort of advanced product development setups and organizations using sticky notes, like literally sticking something to a model in the field. Spreadsheets, emails, meetings, PowerPoint decks, right, is really consuming how a lot of this is done. Meetings in particular are an interesting one. A really common problem that we hear with using meetings as the means to kind of do this design review and capture this feedback is what you see kind of here in the center of the screen. So you take a single team, they have some sort of issue generation meeting. So people come to maybe a 2-hour design review meeting. They're looking at the CAD for the first time ever. One person is there spinning the model, and somebody's got their spreadsheet open taking notes. They're very time-consuming sessions. You need to wait for all the calendars to align, right? And one person might be in Eastern time and the other person's on the other side of the world. So you're asking people to do this sort of complex analysis, make these nuanced decisions, capture these issues at a not ideal time of day. They're probably not always going to be fully ready to jump into that meeting. And so then we see folks are disengaged. So yeah, that right subject matter expert was in the room, but it was 5 o'clock in the morning and they weren't exactly at their best. The other person that we needed there, they declined. We had to go ahead without them. We couldn't wait to find that time. Then they do this long issue generation meeting. Some feedback is documented, some isn't. We found from this survey that 43% of feedback generated during design reviews is never documented or actioned. So there's a lot of that feedback that is getting voiced, but nobody's putting it anywhere or they're misinterpreting it in the way that they put it down. And obviously, the result of this is that things are making it to production that shouldn't, and we end up with a subpar product. So not just that, an issue that could have been prevented becomes a late stage design change. Those are the ones that we find out about. Those are the more obvious. But then as we think about a step change in effectiveness, becoming a significantly more innovative company, well, we're also just missing out on all of that, right? There's this huge opportunity cost in these reactive review meetings versus a more kind of innovative way to engage, let's say, a supplier and come up with a way to do something differently. So an interesting finding from the survey, I think this is probably a love-hate one, probably a polarizing topic. Only 10% of engineering leaders believe that more frequent meetings would prevent miscommunication issues during the design review process. That's interesting because I'm sure the 10% feel very strongly, and I'm sure the 90% are saying, please, no more meetings. But certainly, we see that meetings are often the only option people have, or they feel like they're the only option, but they're often not an effective way to do this review. So this is something we just kind of hinted at, right? So 43% of feedback or issues that are brought up during design reviews is never getting documented or actioned. I think this stat is a very disheartening one for folks to hear who spend hours and hours and hours in design review meetings, late nights, early mornings. Only 57% of those issues are getting dealt with. So we know, right, that something that comes up in production, if the right folks were engaged in any capacity, chances are they probably knew better, right? Like they probably could have prevented that issue. But perhaps they did bring it up, but there was no great way to document it, or there wasn't a way to document it completely or in context, and therefore it just slipped through the cracks and no one was able to do anything about it. So what's the risk of this? A bunch of different things. Companies estimate that roughly half of all issues identified during design reviews are never tracked or addressed, like we just talked about. Low employee morale because of too much admin time, frustrating conversations, late night and early morning meetings. And this can feel like a nice to have, but when we think about, that report we went through in the beginning there, that what the top performing companies are doing differently is really future-proofing their workforce, investing in people so that they want to stay, they want to come to this company, they recognize this company as one of the best in the world. If folks are frustrated with this really kind of manual admin heavy process, ultimately that's going to drive down morale and threaten that maybe they want to go somewhere that doesn't operate in that way. Late stage design changes. So another finding from this survey was that over 90% of companies are having product launches delayed due to late stage design changes. And another finding in asking that same audience was that they felt design review quality was the #1 predictor of product development speed. So we see that those late stage design changes, they're expensive, and they also result in serious delays of getting to market. And then we see, of course, like pretty much every major manufacturing company has a major investment in technology and in building this comprehensive digital thread. But too often that messy middle in that chart we showed gets lost. And unfortunately, if you're using largely these siloed, disparate tools for some of your most important, your most critical design communications, that's never making it back to your digital thread. And so that's why we talk about, why having some sort of purpose-built system to capture all of that instead of all these disparate tools can really become a force multiplier for your PLM implementation. And that's because it really can sort of address that gap in the digital thread where teams are turning to spreadsheets to write down all the things that are of issue, all the things that need to be changed, and that never makes it back to your PLM or never makes it back to the digital thread. So that's another kind of critical risk here. All in all, like the kind of consequences of this, expensive rework, delayed launches, and employee turnover. Critical stuff. And I know it can be challenging to connect the dots on this sometimes to say, yeah, these like long meetings where no one's writing anything down, the consequences of this are your most important KPIs. That can be challenging sometimes to make that leap, but we see it in the data, and we certainly see it. We see it in the industry for sure. So, what do engineering teams need if not spreadsheets, PowerPoints, and meetings? And this is where we get back to this topic of DES. So, in the same survey, we asked what is the #1 way to prevent miscommunication related delays during product development. And we got back a bunch of kind of interesting responses here. So #1 thing, better tools to document design feedback. And when you pair that with this stat that 43% is not getting documented or addressed, that makes sense. Second one here, better processes for managing product data. Third, better tools to communicate design intent, better tools to track and implement design feedback, better tools to communicate design changes. There's some other things here lower down the list on access to PLM training, that sort of thing. All important stuff. But if we look here, we see that better tools to do design review makes up 59% of all of these strategies. So it's a sort of clear gap that folks are recognizing that they need better ways to document design feedback, communicate design intent, track and implement feedback, communicate changes, that kind of stuff. So we see that, engineers want to collaborate better. They want better tools for the job, but they're stuck doing all this admin work to get the right engineering data because this messy middle really hasn't been effectively solved for. So this is where the DES comes in. Our goal, what we do, is to replace that messy middle with something purpose-built. So something really with communication and problem solving at the core, right? That's the core kind of value. That's the core use case. And we call that a design engagement system. So if we think about problem and solution, when building complex products, great decision-making requires specialized expertise. So there's a wide audience we need to engage to get their feedback and make effective decisions. It is no longer a mechanical engineer, an electrical engineer, and a production person that can make all of these decisions and handle all this complexity. There's a lot more expertise. And this means that decision-making is no longer just about a couple of people engaging just with the product data. People really need to engage with other people to make those decisions. And so ultimately, we need a system that is built to bring people together, to share reviews and make decisions with all that context. So the data is still critical here, but the communication is at the forefront. So the point of a DES is to help people interact with other people. So when we compare that to other tools in your kind of typical tool stack, we think about CAD, really built to be an effective design engine. We think about PLM, an excellent sort of system of record. Our intention here is that CoLab is that design engagement system. It's communication first, and it really helps people engage with other people. So what makes a DES a DES? Really 4 key things. The first thing is that it's frictionless. What do we mean by frictionless? Well, it's easy to get data in and out, and it's easy to access the system. You don't need to download anything to participate. And a good kind of litmus test is that it's worthwhile even for infrequent users to come in and help you make decisions. It needs to be, obviously cybersecurity, all that sort of kind of important requirements are considered in this. Like when we say friction, we mean friction in the right places, not the wrong ones. And so it needs to be easy. It's an engagement system. It's got to be easy for a wide audience to engage. The second thing here, it's contextual. So when we think about people interacting with other people to make decisions, these are obviously complex decisions that are being made. So there's a lot of data that needs to be factored into those decisions. So reviews need to be contextual. In a DES, it allows you to pull in all those files, all the feedback, and allow you to visualize it in whatever way you want to be able to make that decision in an effective way. In CoLab and in a design engagement system, feedback is contextual because, for example, it's pinned to model geometry. It's pinned to a particular section on a drawing, and we can then kind of slice and dice that information however we need to down the road to be able to make a really easy decision on design. A DES replaces sequential workflows with engaging reviews. That can be kind of a challenging one to wrap your head around. So the idea in a DES is that everyone can review and mark up the same file at the same time if they want to, or they can do it asynchronously in parallel. When we think about engaging subject matter experts, this is really important, right? Because a critical thing that we hear is that, yeah, those subject matter experts are all over the world, and they're some of the busiest people in the company. So in some cases, being able to do that in real time, like you're sitting in the same room together, is really important. And then other times, it's of equal importance that we can do it asynchronously, and design intent is communicated for you. You don't need to walk somebody through a model at 2 o'clock in the morning just to explain your question or your ask. Because CoLab or a DES is a single purpose-built platform versus many different tools, right? Versus having to leave your PowerPoint deck, go into your spreadsheet, back into CAD, whatever. Because it's a single platform, users don't need to learn hundreds of workflows. They can just work intuitively with these engaging reviews, and the DES kind of guides you through what needs to be done. And then the last one here is that it's self-documenting. So it's really critical that we can take all the admin out of this process. So if we think about that messy middle, it is riddled with admin time. There is, almost as much time spent on admin work as the actual design work. And so a DES needs to be self-documenting. Every piece of feedback needs to be captured as a unique object while you're doing the work automatically. It's not a task to do the review and then write it down. It all happens in one step. That sort of digital thread, that record of decisions and feedback is a byproduct of doing the work, not a separate activity. Then it's important that files, feedback, review activity, all of that, all those sort of outputs of the work roll up into a comprehensive review object. You need to be able to do that for you so you don't have to do it by yourself. So to speak to frictionless, you can see here on the left-hand side, this is CoLab. So when you combine this environment of a PLM plus a DES, you'll see it's really easy to go from that data in PLM to a couple clicks, you're in CoLab, and you're able to conduct that review without having to download any software, without having to have a certain operating system. You could do this from, Google Chrome in a really in any kind of system on a basic laptop. You'll be able to do your review. That's really critical. We talk about engaging a wide audience. Without a DES, if we think about that traditional kind of messy middle, you see downloads, right? You need to go in and download a particular kind of software. You have to ask your suppliers to download or buy a particular kind of software. Or we see, out-of-date data because we don't want people, or we don't have an ability to engage people in a live 3D model. So we take a bunch of screenshots, put it in a PowerPoint deck, that gets sent off to a supplier overseas. They don't know that that CAD has changed. They're now trying to interact and give you DFM feedback, let's say, on an outdated file. And review cycles get constrained by meetings. So we're waiting 2 weeks to get something on the calendar. One person doesn't show, one person isn't engaged, right? So the point of this frictionless is that it's really easy to get people in and get the work done, either in real time together or asynchronously, whatever kind of the situation calls for. Next here is contextual. So it's critical that there's communication between the PLM and the DES in both directions. And you can really easily engage with this data and other people to make decisions. So you can see here on the left-hand side, all of these pins, these are pieces of feedback. They are contextual because as we select them, it brings us right back to that view in the model. So it's easy to get that context. That is the exact same functionality for a drawing, for a bill of materials. We can really easily go from, 30,000 feet looking at everything that's going on across the program, all the way down to a component level on a specific feedback in like 2 clicks. That context is really important for effective decision-making. If we think about the environment without a design engagement system, we see a lot of time-consuming review preparation to build that context, right? They have to build that context out in a PowerPoint deck instead of it just being live here alongside the model. There's context gaps. So even when they build all that out, let's say a particular piece of information is left out, we're seeing all this feedback slipping through the cracks, there's often just gaps, right? It's impossible to sort of recreate everything you need to know in one PowerPoint deck when people can't explore this dynamic environment and learn what they need to learn. Supplier feedback gets scattered in multiple places. So they're often engaged, even if you're doing some sort of, like if the internal process is a little tighter, as soon as you go out to suppliers, it's like Wild West. So feedback is living in multiple email threads. One person engages in a PowerPoint deck, another just picks up the phone and calls you. This feedback is everywhere. It's really critical in a DES that there's smart ways to consolidate that and sort of organize it for you. And then one that's really critical, particularly in compliance-driven industries, no referenceable design history. Because everything is everywhere, someone has to go back and manually create that history instead of it just building itself as you work. So this is contextual. It's really important that everything is in context. Sequential workflows versus engaging reviews. So with PLM plus DES, you can see here in front of you, this is real time. So I could follow somebody through a DES as they spin the model. I can see it spinning on my screen. As they tag me in something, it's instantaneous. I can see that item. It feels like we're sitting in the room together, or it feels like I'm looking over their shoulder. Without a DES, we see slow sequential reviews. So we have to wait for one person before we move to the next. We get a lot of duplicate feedback. One person has to consolidate that. And the workflows are really complex because we're trying to do all this sort of plumbing work in our heads to understand how are all these disparate tools going to fit together? How am I going to get the job done? Putting a lot of sort of mental load into just figuring out that complicated workflow instead of putting all that attention into just doing the work. So that's why that engaging review is more important than that sequential workflow. And the word engaging is really important here, right? Like we're trying to kill this concept of like a looks good review, which is something we hear really often. It's hard to engage in these slow sequential processes. People get tired, and so they just say, yeah, that looks good. When if they really were, presented this information in an engaging way, maybe they would find things that are going to save us a lot of trouble in that rework cycle. And then finally here, the self-documenting. So you can see here in CoLab, as feedback is left on a 3D model, let's say, or on a drawing, it automatically is populating this big global list that's elevating all our feedback, all our issues, all our decisions across the entire environment. And then that can be filtered. Each feedback item has its own URL. It can be sent out. All of this work happens automatically instead of being a separate task in a spreadsheet. And again, the important stuff there, kill the admin work, complete the digital thread, and make sure that the right information is in PLM and we're not cluttering it up with all of this sort of during detailed design feedback and conversations, right? So we don't want 10,000 markups on something and a bunch of things that were never actioned. When we can combine PLM and DES, we can keep the PLM, clean. We can keep it really, really powerful and make sure all this information makes it back, or the right information makes it back, instead of all that information, living in an email inbox that the PLM never gets access to. So that's really kind of the critical components of what a DES is and isn't. So now let's talk about where should engineering teams use it, right? What are the core use cases where that messy middle is really challenging and becomes really critical? And there's really three kind of categories for these use cases. First one, formal design review. So these are those internal reviews, like a review at a gate, maybe drawing reviews, right? So things are going out for production. We need all those drawings to be looked at and reviewed. When you're engaging a SME or someone cross-functional, maybe it's someone from supply chain. ECR or ECN review, like a common use case might be pulling manufacturing into the ECR so that they can understand what change is coming down the pipe and why. And lessons learned in knowledge management. So making sure that lessons learned doesn't sit in a binder that nobody looks at, but it actually is integrated in your PD process. The second category, external collaboration. So we looked at in the beginning, one of the things that these highly productive manufacturing companies are doing differently is they're engaging their suppliers and their customers as a means for innovation. So really thinking about how can we more effectively, earlier and more often engage external people to get better feedback. So that's secure file sharing, so getting them the information they need, supplier and customer co-design, so actually leveraging the expertise of your suppliers to design things better. DFM, ETO, so trying to get better feedback on really customized implementations with your customers, and then sourcing technical review. And then the cost reduction side. So this might look like virtual VA, it's like a virtual cost reduction workshop. CoLab in particular has tools built out for better cost reduction. Integrated VE, so we think of VA on more like the ideation side and that sort of thing, thinking about how do we integrate VE into product development. Idea selection, prioritization, execution, and then the more kind of like BOM and CAD comparative review. So allowing you to look at a BOM and a 3D model side by side and kind of click through there and understand what might be different and what might need to change. So again, I know we've spent a lot of time here, but what makes a DES a DES? It's frictionless, it's contextual, replaces sequential workflows with engaging reviews because it's all in the one place, and it's self-documenting to cut down on admin. So I think it's really important here, if we think about what we talked about there at the beginning, teams who implement a design engagement system and the teams who are outperforming everybody else, they're not settling for 5 or 10% efficiency gains. They're not trying to use digital tools just to augment exactly what they were already doing. They're really looking for a step change in effectiveness. They're looking for new ways to work together, new ways to leverage innovation from one another, from their suppliers, from their customers, make their workplaces more engaging places to work, cut out admin, that sort of thing. when we think about that big gap in productivity between the highest performing manufacturing companies and the laggards that are kind of stagnating, it takes that major effectiveness change. So that's really what this DES is all about. So a couple examples of folks who are doing this and doing it really well. First one, Shuff, so a tier 1 automotive supplier. Really the challenge that they faced first and foremost was maximizing the amount of valuable feedback and action items captured in design reviews. The solution that they implemented, CoLab, allowing them to review designs live or asynchronously with the CAD. All those design conversations get associated with the 3D model and a specific view state, so it's contextual. And then feedback generated during reviews is automatically documented into a database so they can really easily action it. We go from 43% of things getting missed to 0% getting missed. It's automatically going in that table. The impact, capturing more feedback to help you build a better product. Eliminating non-value add activities, like all that admin for collecting things. And then an engineering team that can complete reviews faster, really get through that documentation and ultimately build better products. Next one here is Hyundai Mobis, so another tier 1 automotive supplier. The challenge that they faced primarily was they wanted to work more closely across a bunch of different locations and across their value chain. So whether that's tier 2s or OEMs or whatever, they wanted to work better kind of across that global value chain. Hard to get the right person in the right file at the right time. So actually kind of enabling that collaboration on design file and that sort of thing was very challenging. And there were a lot of changes coming from the OEMs, and they needed to find a way to move faster and move more effectively so they could keep up with all those changes. The solution they implemented was basically leveraging CoLab to share data more effectively with their internal team and with suppliers, and also allowing them not just to get them that data, but then to engage with those 3D files and drawings in a really simple, accessible, frictionless way, and then allowing real-time design reviews for more meaningful engagement and more meaningful RFQs. And they actually were able to reduce design review time by 75% by changing this process. And then the last one here is really that cost reduction focus. So Johnson Controls implemented CoLab on their VA/VE program. JCI has a very mature, very effective VA/VE program, but pre-COVID, it relied on a lot of in-person VA/VE. And then they took CoLab and basically leveraged it to go virtual, which enabled them to reduce the friction on these VA/VE workshops, engage a wider audience, get more reviews, and they would see, up to 100% more ideas generated per event, build that kind of cost reduction idea pipeline so that they could actually implement more and hit their targets. And they were able to achieve some pretty giant VA/VE targets 2 years in a row as a result of making this change. So I know that was a ton of information. We're going to take some questions. If you do have questions, you're still kind of wrapping your head around all of this, feel free to scan this QR code on the screen here, and you can go ahead and book a meeting with us. So if you think there's a topic you want to cover that's really better off kind of digging into a more engaged conversation, or you want to see a demo slower or whatever, we're happy to do that. But if there's any questions right now, please do pop them in the chat, and we're happy to answer them live.
Awesome. Thanks, Taylor. So I just had a question come in. Will we get details on the McKenzie report? Yes, I will send that in a wrap-up email along with the recording, so you'll get all that information. While other people are typing their questions in, I had a couple submitted ahead of time, Taylor. So just wondering, what are some best practices for implementing a DES? So companies who have done it successfully, so you talked about a few just now, how have you seen them approach that internally?
Yeah, I think, it's common that folks try and make the decision of, if this is something that works, we want everyone to use it, which makes sense. What we see as most effective, especially in large organizations, is that we find a sort of one kind of high-performing group, or one group that does well with change, that's a little more nimble maybe, or just has more of an appetite to kind of do things differently. That might be based on the types of products they build, or it might be based on, how frustrated they are with admin or the existing process, that sort of thing, more market pressure. We find a group that's a really good fit, and we get them to implement CoLab. Usually within like 3 to 6 months, we'll have kind of understood exactly how this works for this organization, and then we grow. So then we grow to a couple more business units, then we grow to kind of an enterprise implementation. There's lots of best practices. I would say that's one of the most significant ones, which is this idea of starting with a dedicated group, getting it in the organization, and kind of proving the value to other business units, or other products, programs, however your organization is structured. And then kind of grow into that enterprise implementation is what we would recommend.
Awesome. Okay, next one is interesting. So we'll be implementing a PLM over the next 3 years. How would you prioritize a design engagement system so you don't end up as one of those manufacturing companies who ends up stagnating or falling behind?
Yeah, I mean, I would say like implementing a PLM is definitely a strong step in the direction of being in that high performing category. Depending on the size and level of complexity of the organization, a PLM is going to be, a big help, particularly on data management and that sort of thing. In terms of how to think about implementing a DES while you're on that PLM journey, I would say like the best thing to do is to take that use case lens. So a DES implementation, because it's browser based, there are no big installs. It's a relatively straightforward tool. It happens much faster, right? So it's weeks, not months or years to implement. But I would say think about, across that PLM implementation, probably the like first and foremost things that are going to get addressed is data management, right? Like that's going to be the kind of burning fire, not the messy middle, not the collaboration. So I would think about that. PLM solves data management as the first step. Let's think about the use cases where that messy middle, where that decision-making collaboration is most painful, and look at implementing the DES in that use case lens. So maybe the most painful thing is how you engage suppliers on RFQs. Well, we know, right? You don't want to wait 3 years to learn what the environment looks like with PLM and then add the DES. We can add that on a dedicated use case right away, and kind of grow with that implementation instead of waiting.
Nice, that's awesome. Would you say that a standard PLM system does not offer DES type functionality by default, or any basic engineering review tool?
Yeah, it's a good question. I would say I can't generalize based on every single PLM system. I would say by and large, the core purpose of the PLM, at least for, most manufacturing companies, is really strong data management and workflows for kind of managing that process throughout the life cycle. The core goal of PLM is rarely that person-to-person communication. So that's really the difference. Our recommendation is always to have both. You want that strong record-keeping system, you want that PLM, and DES becomes a force multiplier on top of that to take all of these communications that are living in disparate tools and allowing you to plug it back into the PLM to actually get that holistic digital thread. So I would say like the purpose and the intention of the two solutions are very different, and that's why they complement each other so well.
Awesome, love that. So I'm going to combine these two questions since they're really similar. We're talking about the same engineering software suite. So can a design engagement system, we'll even like specify CoLab if that's helpful, integrate with the latest CAD? And then can you also please share any plans for integrating with PLM or any integrations that are currently in place?
Yeah, so CoLab in particular does integrate with, it supports over 60 different file formats. So there would be full native CAD support for all of the major CAD systems like SolidWorks, NX, CATIA, Creo. Those are all supported in CoLab. So in systems where there's typically a PLM in place as well, our recommendation is always to integrate with the PLM, not the CAD system. But in cases like a SolidWorks and SolidWorks PDM implementation, for example, we integrate directly with SolidWorks and PDM via SolidWorks. And then in terms of integration with PLM, So our primary PLM integrations right now, our primary focus is Windchill, Team Center, and 3D Experience. We see those as the primary tools. Others will come over time. We also have a robust API. So we've had customers, look to build integrations within their data management tools, but the three primary ones right now would be Windchill, Team Center, and 3DX.
Awesome. So you talked a little bit about sequential workflows. Can CoLab work with an already established sequential workflow within your PLM? And if it can, how does that work?
Yeah, so I would say that's something like how does it work is something that we tackle kind of case by case with different customers. It doesn't look exactly the same for everyone. Everyone's PLM implementations look a little bit different. How it works with it most often, I would say, is that PLM is the authority on the release process for a file. CoLab is the authority on the review status of a file. And CoLab or the DES communicates back to the PLM that the file is under review in CoLab, what status it is in, and then any pieces of feedback, any unresolved feedback that still exists on that file. So there's different things we do depending on the implementation, but those are kind of the primary things that are always the same.
Awesome. This is a good one. Is DES a CoLab created category? And have you seen instances where people have tried to create something homegrown that has DES-like functionality to overcome the problems? And I'll even add to Jason's question, like, what have you seen? If you have seen a homegrown one, what has been the implications of that?
Yeah. So is DES a collab created category? I would say there's a lot of talk around system of record versus system of engagement, kind of in general, thinking about what are tools that can bolt onto PLM and add a lot of value to that PLM implementation. Joost Voskuil talks a lot about that. I think he's actually on this call. So he's got a lot of good information about the system of record versus system of engagement. Have we seen instances of homegrown ones? Absolutely, we have. I would say often they are, because they're built to solve the same problem, they too end up being communication oriented. Which is great. I would say where they fall down is often UI UX, right? These are homegrown solutions built by manufacturing companies, not cloud native software companies. So often there is friction. The system maybe isn't as simple of an interface. It's not as easy to use. And then really where it falls down is external. So homegrown design engagement systems rarely have the ability to interact with suppliers or customers in a meaningful way. They might allow you to share data out, but rarely are they going to allow you to have that kind of engaged, review-centric conversation. But they certainly exist. What we've seen in companies where they've either implemented one or are in the process of implementing one is that they're delighted when they come across CoLab, because manufacturing companies often don't want to build and maintain their own systems. And when they see that, a dedicated software company uncovered the same problem and built a purpose-built solution for it, that's often good news. And we've replaced lots of those kind of homegrown solutions.
Awesome. So this one's interesting. So I have a PLM workflow that involves a cross-functional team. So both internal design team and then plant engineers. How does DES also help them in decision-making?
Yeah, so I'm understanding the question as how does a DES help a cross-functional team? So between design and plant and decision-making. There's a couple different places. The first one is, and perhaps the primary one that comes to mind, is just a really engaging seat at the table. So a DES gives folks in the plant, for example, the ability to look at 3D, not just like a print on the wall, but actually look at a 3D model, spin it themselves, engage with it in, it's easy to do in CoLab. You don't have to have been, a CAD designer for 20 years to be able to interrogate a model, get the information you need. But then also because it is this review-centric environment, those folks in the plant can really easily give their feedback upfront. So if you remember those two charts, the red and the blue, we want those plant folks to get involved earlier in a more engaging way so that we can pull that risk out, right? You don't want to find out that that decision is not going to work in manufacturing, really late in that process. We want to pull that forward as much as we can. So that's often what it allows them to do is engage with the CAD in a really simple way, give feedback in a really simple way. And because it's easier, do it earlier so that we can pull the risk forward. So they're not finding out about this stuff at the last minute when it's, difficult or time consuming to change.
Great. Can you talk about how using CoLab to track feedback is different from saving annotations directly to the part record in PLM?
Yeah, that's a great question. So there's a couple differences. I would say the use cases for those things are typically different. So CoLab is review centric. So we believe that there's more to a design review than just a markup on a file or a markup on a part. So really CoLab allows you to upload all that data or push that data in from PLM and then conduct that design review. So having multiple stakeholders invited to that review, the review really functions as an event. They then have all of these feedback and communication tools to be able to weigh in and give their opinions. They can do that real time or they can do that asynchronously. All that information comes in. It often is nuanced. There's a lot of feedback. Some gets used, some doesn't. All that feedback is contextual, right? So it's linked to the 3D model or to a model in a drawing or whatever. And then it all rolls up into a feedback table so you can really easily prioritize and action it. When we think about the ability to save annotations directly to the part record in PLM, often we see the use cases for that are distinct decisions that have been made on a released file. We want to make that note for somebody. Often that's not a collaborative decision-making process. It's more a simple kind of static annotation. So really it's use case oriented. There are times when you want to do that. Like let's think about a cost reduction landscape. If you're doing a virtual VAVE event with 40 stakeholders, you don't want those 40 stakeholders all annotating that part in the PLM. That will be a mess, right? It will be hard to then find the really critical things that need to be pinned to the top. Whereas if there's a critical note about a particular part, it's really easy to annotate that on the PLM and have it sit there on the release file. So the functionality is very different because I think the intentions are very different of those two tools.
Awesome. This is a really specific one. I don't know if you want to answer it live, Taylor. We're also going to send a video that showcases this specifically in the wrap-up email. But can you tell us how CoLab's DES integration with PTC Windchill or Siemens Teamcenter is set up? Like, how does that work exactly?
Yeah, absolutely. I think we actually do have a video here I could show you. Do a live demo. There we go. Let me just
CoLab to then review with the team.
Listen to
From within Windchill, I can
it.
simply
Okay. So
share.
if you can see
It could
this,
be
okay.
could be
There we go.
from direct.
Technical difficulties. So basically, what this allows you to do, you can see in Windchill, a particular part, or in this case, 3 components were selected. I can right-click them, share to CoLab. It then allows me to identify the place I want to share it in CoLab. So in this case, it's a particular workspace. That's then going to get uploaded. Once it gets uploaded, it's going to get converted. The integration will allow you to do this for, in this case, we're looking at Windchill. So for native CAD, WT parts, WT documents, whatever you need. Then from right here, you can open the workspace or you can go into CoLab and see it. But also information is going from CoLab back to the PLM. So if we actually go to a particular part, so you're going to see here as we just search for a particular component that was shared, we can come in here and see basically where does this live in CoLab. So we can see what workspace it's in. We can see the status of the current review. So it's in an open state. And we can see that there's one piece of unresolved feedback that lives on that file. And then obviously we can click and be brought directly to that context in CoLab. We can even click and be brought directly to that one unresolved piece of feedback. So there's, of course, more to this integration. That's just kind of the core functionality, is really all about the ability to get data in and then send metadata about the review back into the PLM.
Great. We have no other open questions, Taylor. You did a great job.
Nice. Thank you, everyone. Those were so many like thoughtful and specific questions. So that's great. Thank you.
Awesome. Thank you guys, everyone, for joining. As I've said a couple of times, we will send a wrap-up email with both the recording, the link to this Windchill plus DES collab video, so how the integration works exactly. We'll also send a link to that McKinsey report, so you guys have all the information there. And of course, then you can always respond if you have any questions to that email, and I will make sure you get sent to the right person. So thanks again for joining. Really enjoyed your time. Thank you so much, Taylor, for hosting this event, and we will see you guys next time.
Thanks, everyone.